Hi geometry students. These videos are on problem solving with Trig, or that's an abbreviation for trigonometry. So you should have downloaded and printed out the worksheet version of this, but I have just kind of written out the problems because I do not have access to a printer. So if you also do not have access to a printer, you could just kind of write things out as you go, just like me. It just might take you a little bit more time. You might have to press pause at certain points to write out your diagrams. So to start, I'd just like you guys to kind of use what we learned last class about the different trig ratios, remembering the SOHCAHTOA is your abbreviations for remembering what ratios to set up, and go through and figure out what are the values for each triangle of sine of x, tan of z, and cosine of x. And then, so pause the video, try those out, and then press play to see the solutions. Okay, so by now you should have already paused and then pressed play again. So now I'm going to run through how I think you should do these problems. So for sine, I know that's opposite over hypotenuse, and the angle I'm thinking about is angle x, which is right here. So the opposite side would be right there, the 24, and then the hypotenuse is across from the right angle, so that would be the 26. So I'd say 24 over 26, and I can simplify. I could divide both of those by 2, so I could get 12 out of 13 as my sine value. Okay. For the next one, I have tan of z. So angle z is over here. I know tangent is opposite over adjacent, TOA. So the opposite side to angle z is the 8, and the adjacent is the 6. Keep in mind, I know that 10 is neither because 10 is the hypotenuse, right? So then I should get 8 over 6 for opposite over adjacent. And again, I could divide by 2 to simplify and get 4/3. Okay, so now for cosine of x, angle x is up here, and cosine is adjacent over hypotenuse. So I forgot to draw on my right angle, but it is right there. So adjacent would be the side next to the angle x that's not the hypotenuse. Hypotenuse would be across from the right angle, and this would be adjacent. So adjacent over hypotenuse would be 24 over 30. And then I could simplify that by dividing top and bottom by 6, and I would get 4/5. Okay, so that is just to review. Do we understand what it means when we say sine of an angle x? Yes, it means set up the ratio of the sides of the side opposite to the hypotenuse. Here, tangent means adjacent. Set up the ratio of the side opposite over adjacent, compared to angle z, and then cosine of x means set up the ratio of adjacent over hypotenuse. Okay, so now we're going to see how we can use these trig ratios to find an unknown value. So we're going to look at how we could find an unknown side first, and then later we're going to look at how we could solve for an unknown angle. Okay, so here I'm saying solve for an unknown side. So the key is we're going to set up a trig ratio that involves the given information of the 63-degree angle and the 11, the length of the one leg. And we're going to try to set up a ratio that involves this information plus the angle, the side I'm trying to solve for. So if I'm thinking about angle 63, then the two sides that I have given would be 11, which is the adjacent side, and x, which is the opposite. Now, I'm neither trying to find the hypotenuse nor do I know it, so I'm not even going to consider it. So what does that mean? That means that I should set up the trig ratio that involves both the opposite and adjacent sides. That's tangent. So I want to set up tangent here. So I do tan of 63 is equal to x, opposite, over adjacent, 11. And now I've set up a equation that is true because I know tan of the angle here should be the opposite over the adjacent side. And this allows me to solve for x. How does it allow me to solve for x? Well, I could isolate x by multiplying both sides by 11. Now I'm going to get 11 times the tangent of 63 is equal to x. Now, I don't know exactly what that is, but this is the point at which I would get my calculator involved, because my calculator can calculate trig ratios for any angle. And so I'm sliding in my little graphing calculator. Please make sure you have your graphing calculator. You could also use a scientific calculator, but you need a calculator. The first thing I want you guys to do on your calculator is push the mode button and check to see that your calculator is in degree mode. So if you scroll down to where it says radian degree, one of those two words should be highlighted in black. So mine right now, the word degree is highlighted, so I'm all set, but it could have been that yours looks like this, in which case radian is highlighted, and then I would want to come down and arrow over to be highlighting degree, push enter, and then it switches from radians to degrees. I must be in degrees in order to get the correct answer to these trig problems. So please send me a message if you're having problems doing that. Okay, so now that you're in degree mode, and on a scientific calculator, there's probably a button that says like rad/deg or something like that to switch back and forth between radians and degrees. Okay, so that all being said, if I just type the word, so there is a sine, cosine, and tangent button on your calculator. If you let me push it up. So it's sine, cosine, tangent. So right now I'm interested in tangent. So if I type tan and then 63, the calculator will spit out the ratio value of tangent for a 63 degree angle, no matter what triangle I'm in. So I know tan of 63 is this long decimal. I would then want to multiply that by 11. So I could do it one of two ways. One way is to type tan of 63, and then if I immediately just push the multiplication sign, it pulls my previous answer, and then I could say answer times 11 and get my answer. I could have also just typed in one line, tan 11 times tan of 63 and gotten the same answer. Now, the key is that I'd rather not round until the very end. So then I would get, this is the point at which I would round. So I'd say x is approximately, and I'm going to round to the 100th. So I'd say 21.59. And that would be the side length of that missing side. Okay. So what I want you guys to try to do now is pause the video and see, can you set up a trig ratio for number 5? Thinking about if I'm trying to relate x, 17, and 39, what trig ratio would I set up? So pause the video, set that up, then press play. Okay, so by now, hopefully you've tried to set up the trig ratio, and I'm going to talk you through it. So here I see that 17 is the hypotenuse because it's across from the right angle, and x would be the opposite side compared to 39 because it is straight across from 39. So if I have opposite and a hypotenuse, that's telling me I should use so, right? I have O and H. So that would be sine of 39 degrees. And that should equal then the opposite over the hypotenuse. So I would say x over 17. Okay? So now this is the trig ratio. Now again, I'd like you to pause the video for a moment and see if you can solve for x and then use your calculator to get an approximation for the value of that missing side. So pause the video and then press play when you're ready to see my solution. So my solution would be to first isolate x. So I'd multiply both sides by 17. That cancels out the denominator of 17 on the right. So now I know that 17 sine of 39 degrees is equal to x. And this would be the point at which I get my calculator. And I'm going to just type it all in on one line. I'm going to type 17. And remember your sine button. So sine, oops, I pushed the wrong button. Sine of 39 degrees. And I get 10.698. So I'm going to round that to 10.70 for my value of x. Okay, so now we have one more to try. So again, I want you to pause the video and see if you can set up the trig ratio, then press play to check. So now you should have tried to set up your trig ratio and press play, and I'm going to explain. So I see that the x is actually across from the right angle, so that's my hypotenuse, and 11 would be the adjacent because it's right next to my 60 degrees, so that's ca. So I want to set up cosine And that would be, so cosine of 62 degrees is adjacent over hypotenuse. That'd be 11 over x. Now, at this point, solving is a little bit different because x is now in my denominator. So if you want, you could pause the video and see if you can figure out how to solve this algebraically, and then press play to see how I solved it. Okay, so what you need to do is actually, you do the same first step as you did in the last two, which is you multiply both sides by the denominator, but in this case our denominator is x. Now when you do that, those x's cancel on the right, and I get x times cosine of 62 equals 11. Now if I'm trying to isolate x at this point, I want this x by itself, and right now it's being multiplied by cosine of 62, which is a number. So what I'm going to do is I'm going to divide both sides by cosine of 62. That cancels it off on the left-hand side. So now I know x is equal to 11 divided by cosine of whatever 62 degrees is. This would be the point at which I get my calculator. And I can actually type that division right into my calculator. I could type in 11 divided by cosine of 62. And I get, for x, I get approximately 23.43. So that's where your algebra gets a little bit trickier, is when you set up your ratio and the side you're looking to find is in the denominator. That's when you have to multiply both sides by x, or your variable to begin with. Okay, so that is examples of solving for an unknown side. Next thing we're going to look at is how do we solve for an unknown angle using trig. So, using trig to find angle measures. So in this diagram, we have a question mark for that angle measure. So we're trying to solve for that question mark. I'm going to replace it with a variable. I'm going to just call it x, just for simplicity's sake. So if that's x, and I want to set up a trig ratio that involved x, well, what two sides do I have? I have the opposite and the adjacent. So if you could take a moment and think about, like, what would the trig ratio you set up be, and what would it look like? So you could pause the video and try that out, and then press play. So if I have opposite and adjacent, I'm thinking about tangent, TOA. So I could say tan of the angle, right? So that's tan of x should equal 27 over 38. Now at that point, I haven't showed you how do you undo tangent and get the angle by itself. And it's not just dividing by tangent, because tangent is like a function. It's not multiplication here. I can't divide it away. So tangent and x are tied up with each other, right? They're connected. The best thing I can do is there's this trick, which is this button on the calculator. If you look at the sine, cosine, and tangent buttons, up above them in blue, you'll see written sine to the -1, cosine to the -1, and tangent to the -1. And we say sine inverse, cosine inverse, tan inverse. Essentially, they're undoing what the other operations, what tangent or cosine or sine is doing. So essentially, I could do, so here in the tan of x equals 27 over 38, this is, we do tan of an angle, and we spit out a ratio, right? So now the reverse, or tan inverse, says take tan inverse of a ratio and it will spit out the angle, okay? So it tells me for a given ratio what's the angle that goes with it. So for our purposes then, if tan x equals 27 over 38, that means tan inverse of 27 over 38 should tell me the value of x. So if I type that in my calculator, and again, in order to get to the blue buttons, you have to push the blue second button first. So I push the blue second button, and then that little arrow appears. And now I'm going to push the tangent button, and it's going to select tan inverse, or tan to the -1. And then I would type in 27 divided by 38, and it should spit out an angle. So the idea is that tangent of 35.3947, etc., should give me the value of 27 over 38. So now I know that x is approximately 35.59 0.39 degrees. Okay, so moving on to the next one, let's see. I'm again going to say where the question mark is, let's call that X. Now I'd like you to pause the video and try to set up your trig ratio. If you want, you can kind of go through the whole process of solving and see how far you get before you're confused. Then press play to see my solution. Okay, so in this problem, you should have tried it already. I see where my angle X is, and then I see I have the angle across from it, that's the opposite, and I also have the angle, the side across from it, and I have the side across from the right angle, which is the hypotenuse. So I have opposite and hypotenuse, that's sine, so I should do sine of X should equal opposite over hypotenuse, 40 over 42. And then the idea is now is the time to use inverse sine. So I'd say that means sine inverse of 40 over 42 should equal X. Now I'm going to use my calculator at this point and do second sine of 40 divided by 42. And I spit out 72.2472, etc. So if I'm rounding to the hundredth, which I'm generally going to do here, I get 72.25 degrees for X. Okay, so again, give this next one a shot. What's written here is a Greek letter. It works like a variable. It's called theta. It looks like kind of like a zero with a line through it. This is theta, and it is a Greek letter that is commonly used as a variable to solve for angles. So again, press pause, try this out, then press play to see my solution. Okay, so my solution would be I have the adjacent side and I have the hypotenuse. So that is AH, cosine. So I would do cosine of theta is equal to 4 over 5. And that means cosine inverse of 4 over 5 should tell me theta. Getting my calculator. Typing in second cosine, get cosine inverse of 4/5, and I get a theta value of 36.87 degrees. Okay, now if you do not have a graphing calculator, you could do this on a scientific calculator. You could also do this probably on like some other online calculator. You just need to make sure you're in degrees, not radians. I'm also going to post a short video of how you can use a chart to find these values, which will be optional for anyone who is struggling to access a calculator. Okay, so I have one more problem that I want to look at with everyone, and that is, so first of all, right now what we've done is we've figured out how we can use trig to solve for unknown sides and unknown angles, and now we're going to start to see like what types of problems that can allow us to solve. And one of them is this next one, which is how do we find the area of a regular octagon with a side length of 4 centimeters? So to do this one, I'm going to draw a picture of an octagon. So I'm going to try to make it look as regular as possible, but it's not going to be perfect. Okay, so there's my octagon. Maybe on your worksheet, I'll actually put an actual diagram of an octagon so you don't have to draw this. So the visual picture here is that we can divide this octagon into 8 congruent triangles, right? And then we also knew that all these side lengths are the same. And one of those side lengths is 4 centimeters, right? So this is my diagram, and essentially is if I can find the area of one of those triangles, then I should be able to find the area of the entire shape. Now, to get the area of one triangle, I'm actually going to start in maybe an unexpected place, which is I'm going to find the angle of one interior angle in an octagon, because I know that's something I can find, and I know angles are helpful in trigonometry. So an interior angle in a regular octagon is this 180 times n minus 2 over 2 formula, and where n is 8. So this becomes 180 times 6, because that's 8 minus 2, over 8. And that gives me 135. So now I know that one angle in the octagon is 135, but that's not an angle in one of my triangles, right? Because that's like this whole 135 degrees. So I know half of that would be the angle in my triangle, though. And half of 135 is, let's see, 135 divided by 2 is 67.5. So I know 67.5 is actually one of my angle measures in this triangle. And I'm going to start with my triangle. So I'm going to redraw my triangle. So this represents kind of like just one of these. So if I were to take that one and zoom in, then I'd say, okay, I know that angle there is my 67.5 degrees. I know this is 4 centimeters. And I don't have any right angles in this diagram, but I could get a right angle by dropping an altitude. And I know since these two lengths are the same, that splits my big triangle in half, which means that this has a length of 2 centimeters. Okay, so now that then allows me to solve for my altitude. I'm just zooming in a little so you can see a little better. So within this triangle, can you see how if I set, say, like a variable equal to my altitude, so say I call my altitude x, then I have enough information to solve for x, my altitude. Why do I care to have that? Well, if I want to know what the area of this triangle is, I need the base of it. I have that. It's 4. Times the height of the triangle. Well, the height is that altitude. So that's where I need to solve for x. So I could say, well, if I want to solve for that x, this is trig. I have the angle. I have one side. So which trig ratio do I need to set up? Well, think for a second. You can even press pause. I have the opposite and I have the adjacent side. So I should set up tangent of 67.5 is equal to x over 2. Using 2 because 2 is the side length in the right triangle. Then I would say 2 tan of 67.5 should tell me what x is. And if I type that into my calculator, 2 times tan of 67.5, I get x is approximately 4.83. Okay, so from there, now I can know the area of the triangle, which should be approximately 1/2 of the base. Again, now for the base, I'm doing the whole triangle at this point, right? So my base is actually 4, and then 4 times the height, and the height is at 4.83. Okay, well, that's going to give me essentially 4.83 times 2, which is 9.66. And now I have to come back to my original diagram and realize, well, that one triangle, there's actually 8 of them in the octagon. So if I want the octagon, and oh, by the way, my units are centimeters squared. So if I want the area of the octagon, it's got to be 8 times the area of one of the triangles. So if I do 8 times 9.66, I get approximately 77.25 centimeters squared. Okay, so these are your notes. You have textbook problems to practice. There are hints posted, so please use the hints to help you work your way through those problems. And there's going to be a live video chat debrief, and I will be recording that video chat, so if you have questions but miss the video chat, you'll be able to watch a recording of it. All right, guys, good luck with your first day of distance learning.